Okay, I will be talking about the primary and secondary responses. So first I'm going to start out with the primary responses, and this is of the adaptive immune system. So our primary immune response, this happens when a foreign antigen is invading our body or the host for the first time ever. So the body that has no recognition of this antigen because it's never seen it before. So when this happens, a slow immune response happens. Primary immune response is very slow. And this is because it has to take the time to recognize the antigen, but not only recognize the antigen, it has to take the time to learn how to make the antibody to fight off the antigen. So it's a very slow process. So during primary immune response, we have key lymphocytes. These key lymphocytes are going to be the naive B and T cells. So the naive B and T cells are the responding cells in the primary. So we'll start with the B cell. So we're going to talk about the B cell. So the B cell, when it is activated, so the foreign antigen invades the body and the B cell is activated. When it is activated, it secretes antibodies. And these antibodies are known as immunoglobulins. So when these antibodies are secreted, they're moving around the bloodstream. And once they see the foreign antigen, they'll bind to the foreign antigen. So this binding causes two things to happen. And these two things are very, very vital, important things for the process, the primary immune response. So when the immunoglobulin binds to the foreign antigen, the first thing that will happen is it will inactivate viruses and toxins. And it inactivates these viruses and toxins by enabling them to bind to the receptors of the host cells. So when it does this, they no longer work, they're inactivated. And then that's the first thing it does. So the second thing that the binding does is that it will mark the pathogen for destruction. And it marks them for destruction by making it easier for the phagocytes to eat them, to ingest them. So that's the two things that will happen that comes from the immunoglobulins that are secreted from the B cells to bind to the foreign antigens. Those two things happen. So now we're going to move on to the next one, which is the T cells, which is still a responding cell to the primary response. So T cells will react directly against the pathogen. So unlike the B cells that release the antibodies to fight, the T cells react directly. So here's two examples. I'll give you two examples. So the first example is a T cell can kill the host cell. So say we see a host cell. So this is our host cell, and all of these things sticking out on the side are going to be the foreign antigens, right? So we see this virus-infected host cell, and if the T cell kills this host cell, the virus can no longer live. It can no longer regenerate. So that's one thing that we'll do. So that's the T cell just directly affecting the foreign antigen. And the other thing it can do is it can release these how should I say it? It can release these molecules that will send out a message. So these molecules will send out a message to macrophages, and these macrophages will then kill any invading microbes. So it's not releasing antibodies like the B cells do, but it is sending out signal molecules, and so these macrophages will go out and they will kill them. So those are two examples of how T cells can directly kill the antigens during the primary response, the primary immune response. So now we're going to move to the secondary response. So the secondary response, their responding cells are called memory cells. And they are rightfully named this. I think it makes it really easy to remember what they do. So these memory cells are the responding cells, as I said, to the secondary immune response. So these memory cells are kin, they're family to those naive B and T cells that we had working in the primary response. So they are going to just, when they are ready to work, when they are enlisted to do work against the antigen that we're going to see. So the antigens we're fighting during the secondary response are antigens that we've already seen once. So this will be their second or third or fourth or etc. times to invade our body. So that's why, as I've said, they're called memory cells, because we have a memory of them, or our body has a memory of them, our immune system does. So these memory cells will get enlisted to fight this antigen, and they'll just jump in right where it was left off from the naive T and B cells. They'll just jump in and start fighting, and as they're fighting, they're becoming better at fighting this antigen, and better and better and better as they continue to fight. This is a very rapid response. It's a lot faster than the primary response, and I will show you that in a chart in just a moment, but it's a lot faster than that response because it doesn't have to take the time to re-recognize the antigen. It doesn't have to take the time to learn how to make the antibodies because it's already been done for them during the primary response. And that's, as I said, that's why it's called memory cells. These memory cells can last for decades. Like, they can even last even after the conclusion of the primary response. Like, these memory cells can last for decades. That's why we can get sick and our body can fight it off a lot faster later down the road when we get sick again. This is exactly why, because of our primary response doing its job, and then that would be our secondary response. So I'm going to show you now with a chart. We're going to compare the primary and secondary responses. So I'm just going to draw a graph, and on the x-axis I'm going to put time, and on the y-axis it's going to be antibody concentration. Antibody concentration time on the x-axis. So I'm going to first show you the primary response. So this line will be the primary response, the started line here. So we're going to start here and it'll just go like that. That'll be our primary response. So then here will be our secondary response, this line right here. So we'll start here and then we'll go like that. So primary, secondary. Let me write that up there so I'm clear. That is the secondary response. This is primary, secondary. So as we see here, there's not room here, meaning that the concentration is very low. As I stated earlier, the primary response produces very few antibodies, especially compared to the secondary response. Look at this difference in the concentration. This is a huge difference in concentration. So the secondary response produces a lot more antibodies. It also, as we can see by the slope, happens a lot faster, some very more rapid than the primary. And as I stated earlier, that's because we don't have to take the time to re-recognize the antigen or re-recognize how to make the antibodies to fight it. So we make more antibodies with the secondary response, and we also, it's a lot faster response, more rapid response than the primary. Another difference is the main antibody in the primary is the main antibody produced during the primary immune response is going to be the IgM. And then the main one produced in the secondary is going to be the IgG. Now, with that being said, some IgMs in small amounts can be produced in the primary, in the secondary stage, but not many. Just as well as some IgGs can be produced in the secondary stage, but not many. So, but this one is main for the primary, and this one is the main antibody produced for the secondary. So we compared the primary and the secondary immune responses.